When a transformer is not located in the same room as its overcurrent protection, a disconnecting means is generally required at the transformer's location. This requirement is in place to enhance safety and facilitate maintenance procedures. The primary reason for this requirement is to allow personnel working on the transformer to safely de-energize it locally without having to travel to the remote location of the overcurrent protection device. This is particularly important in situations where the transformer is supplying critical loads or where a fault condition requires immediate isolation. The disconnecting means must be readily accessible and clearly marked to indicate its purpose. The National Electrical Code, or NEC, provides specific guidelines regarding the installation and location of disconnecting means for transformers. It is essential to consult the relevant sections of the NEC to ensure compliance with these requirements. Firstly, the disconnecting means must be capable of interrupting the full load current of the transformer. This is crucial to ensure that the transformer can be safely de-energized under normal operating conditions. Secondly, the disconnecting means must be rated for the voltage and current levels present at the transformer location. This ensures that the disconnecting means can withstand the electrical stresses imposed upon it during operation and fault conditions. Thirdly, the disconnecting means must be installed in a readily accessible location. This allows authorized personnel to quickly and easily de-energize the transformer in the event of an emergency or for maintenance purposes. Fourthly, the disconnecting means must be clearly marked to indicate its purpose. This helps to prevent accidental de-energization of the transformer and ensures that personnel are aware of the location of the disconnecting means. The specific requirements for the disconnecting means may vary depending on the size and type of transformer, as well as the specific installation conditions. It is essential to consult the NEC and other applicable standards to determine the appropriate requirements for a given installation. In some cases, the overcurrent protection device itself may serve as the disconnecting means, provided that it is readily accessible and meets all other applicable requirements. However, in many cases, a separate disconnecting means is required to provide an additional level of safety and convenience. When selecting a disconnecting means for a transformer, it is important to consider the following factors. Firstly, the voltage and current rating of the transformer. The disconnecting means must be rated for the voltage and current levels present at the transformer location. Secondly, the type of enclosure required. The disconnecting means must be installed in an enclosure that is suitable for the environment in which it is located. Thirdly, the method of operation. The disconnecting means must be easy to operate and maintain. Fourthly, the applicable standards. The disconnecting means must comply with all applicable standards, such as the NEC and underwriters' laboratories, or all standards. In addition to the requirements for a disconnecting means, it is also important to ensure that the transformer is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect personnel and equipment from electrical shock. The NEC provides specific guidelines regarding the grounding of transformers. It is essential to consult these guidelines to ensure that the transformer is properly grounded. The specific grounding requirements may vary depending on the type of transformer and the specific installation conditions. It is important to consult the NEC and other applicable standards to determine the appropriate grounding requirements for a given installation. In some cases, a separate grounding electrode may be required to provide an adequate grounding path. This grounding electrode must be installed in accordance with the NEC and other applicable standards. Furthermore, transformers must be installed in accordance with all applicable electrical codes and regulations. This includes requirements for clearances, ventilation, and fire protection. It is important to consult the NEC and other applicable standards to ensure that the transformer is installed in a safe and compliant manner. The specific installation requirements may vary depending on the size and type of transformer, as well as the specific installation conditions. It is also important to consider the environmental conditions in which the transformer will be operating. Transformers that are installed in harsh environments, such as those with high humidity or corrosive atmospheres, may require special enclosures and other protective measures. These protective measures help to prevent damage to the transformer and ensure its safe and reliable operation. In summary, when a transformer is not located in the same room as its overcurrent protection, a disconnecting means is generally required at the transformer's location. This requirement is in place to enhance safety and facilitate maintenance procedures. It is essential to consult the NEC and other applicable standards to ensure compliance with these requirements. Additionally, the transformer must be properly grounded and installed in accordance with all applicable electrical codes and regulations. This comprehensive approach to transformer installation helps to ensure the safe and reliable operation of the electrical system. Let's delve deeper into the specific aspects of transformer disconnect requirement, focusing on practical applications and common scenarios. Firstly, consider a large industrial facility where a transformer is located in a dedicated substation, while the motor control center it feeds is in a separate building. In this case, a disconnect is absolutely necessary at the transformer to allow for safe maintenance and troubleshooting of the transformer itself. Without it, any work on the transformer would require coordination with personnel at the motor control center to de-energize the circuit, which can be time-consuming and potentially hazardous. Secondly, think about a commercial building where a transformer is located on the roof, supplying power to HVAC equipment. Here too, a disconnect near the transformer is essential. Imagine a scenario where a technician needs to work on the HVAC system. They would need to have a readily accessible means to de-energize the transformer feeding the equipment, ensuring their safety. Accessing a remote overcurrent protection device, possibly located in the building's electrical room, would be impractical and increase the risk of accidents. Thirdly, let's examine the case of a data center. Data centers rely on uninterruptible power supplies, or UPS, systems and multiple transformers to ensure continuous operation. Even with redundant systems, maintenance and repairs are inevitable. Disconnects at each transformer allow for isolation of individual transformers without affecting the entire data center's power supply. This minimizes downtime and enhances the reliability of the entire system. The type of disconnect used can vary depending on the application and the transformer's size. For smaller transformers, a simple fuse disconnect switch might suffice. For larger transformers, a circuit breaker or a more robust disconnect switch may be required. It's also crucial to consider the environment when selecting the disconnect. For outdoor installations, a weatherproof disconnect is necessary to protect it from the elements. For indoor installations, a general-purpose disconnect may be adequate. Now let's discuss some specific NEC articles that relate to transformer disconnects. NEC Article 450.14 covers the accessibility of transformers. It requires that transformers be readily accessible for inspection and maintenance. This implicitly supports the need for a local disconnect to facilitate these activities. NEC Article 450.3 addresses overcurrent protection of transformers. While it focuses on the overcurrent protection device itself, it also indirectly reinforces the need for a disconnect. Proper overcurrent protection is essential, but a disconnect provides an additional layer of safety by allowing for complete isolation of the transformer. In addition to the NEC, other standards and regulations may apply, depending on the location and type of installation. Local building codes, utility company requirements, and insurance company guidelines may all have specific requirements for transformer disconnects. It's essential to consult all applicable codes and regulations to ensure compliance. Moreover, proper labeling and signage are critical for transformer disconnects. The disconnect must be clearly labeled to indicate which transformer it controls. This prevents confusion and ensures that the correct transformer is de-energized when needed. Signage should also include warnings about potential hazards, such as high voltage. Regular inspection and maintenance of transformer disconnects are also essential. Disconnects should be visually inspected for signs of damage or corrosion. They should also be tested periodically to ensure that they are functioning properly. Any problems should be addressed promptly to prevent equipment failure and ensure safety. The location of the disconnect is also an important consideration. It should be located as close as possible to the transformer to minimize the amount of energized conductor between the disconnect and the transformer. This reduces the risk of electrical shock and arc flash. The disconnect should also be located in a readily accessible location free from obstructions. This allows authorized personnel to quickly and easily de-energize the transformer in the event of an emergency or for maintenance purposes. Furthermore, proper training is essential for personnel who operate and maintain transformer disconnects. Personnel should be trained in the proper procedures for de-energizing and re-energizing transformers. They should also be aware of the potential hazards associated with working on electrical equipment. Training helps to ensure that personnel can safely and effectively operate and maintain transformer disconnects. Finally, remember that safety is paramount when working with electrical equipment. Always follow proper safety procedures and use appropriate personal protective equipment, or PP. If you are not qualified to work on electrical equipment, consult a qualified electrician. By following these guidelines, you can ensure the safe and reliable operation of transformers and the electrical systems they serve. In conclusion, the requirement for disconnecting means that a transformer, when the overcurrent protection is remotely located, is a critical safety measure. It provides a local point of isolation, allowing for safe maintenance, troubleshooting, and emergency de-energization. Compliance with the NEC, other applicable standards, and best practices is essential to ensure the safety of personnel and the reliable operation of electrical systems.